Very good. We can see only 3 in the class today, including myself. Only 3 today. Anyway. Okay. Have you heard of the software CoolPack? CoolPack කියන software එක අහලා තියෙනවද පුතාලා?
Never heard before.
Never heard before. Okay. But we have to, anyway, let me guide you to download it. That is very useful. So you can, what you can see is a CoolPack one page here. So let me start CoolPack from the beginning. Let's say I exit this. So let me share the screen first. I will share it to the desktop first. CoolPack, let's see, CoolPack. Yes. Can you see the screen?
Yes, sir.
Yeah. So this is the CoolPack software. This is not only for the refrigeration. Then you can go for any of the properties of mainly the liquid and vapor. You can really use this. So example, let's say if you want to take the properties of any practical refrigerant, let's say here you can see. So what I did was I click here, saturation. Then here I need to select the refrigerant type. Refrigerant means the liquid, whatever, even the water, ammonia, anything is here. Let me take water here. I need to look for the properties of water. Okay. Okay. Water. You will get the table for the saturated water and steam. So this is going to be the table. Yeah.
Sir, we can't see change of the screen. It's some kind of freezing screen. Refrigeration utilization.
Okay. Yeah. Thank you very much for the feedback. Now this is after clicking that I can get this table out of that software. Okay. Yeah. So let me open one more and I will share with you again. Let's say I need to get the for the temperature entropy diagram. Let's say for the water.
Okay.
Again for the water. So I click water. Okay. Yeah, we will get the temperature entropy diagram. I will. Yeah, you got it. You got it. That's the use of this. Even if I need to get another pH, generally we use in refrigeration. Let's say we are going for another one. There are so many. So let's say ammonia. You will get the curve. And after that, when you move the curve, this area you can see the values. Right bottom. You can see the values. So this is a very important software. So now I'm going to help you to download this. I'm going to help you to download this so we can use this. So let me go to, so I'm going to stop this sharing, and I'm going to open up a website for you to download. Okay, I'm going to open up a website for you to download. Let's see. I'm going to share the Google screen, and if I type here cool pack, okay, cool pack, ESCK, cool pack software, okay. This is from the Technological University in Denmark. So I believe this should be the first one, should be cool pack. Yeah. Let's see what is this. What is the home here? Let's see. What is this? DTU, yes, DTU. Denmark Technological University. You go to this website, and now earlier we were in the full pack download. Full pack is here. So anyway, you can go through this. So download cool pack is here under download. Cool pack version 1.5.0. Even the professionals are using this because this is a very wonderful database that everyone should have. And luckily, this is free. It's a very valuable database, and this is free. I have been using this since 2002. Since 2002, not only this, but when we need the data, the properties of the liquid, vapor, and the two-phase, this is wonderful. And every time, frequently, they do the updates. Yeah. So you go for the download, you click this, this is downloading here anyway. Yeah. So it starts immediately downloading. So I have my own spool pack installed here in my notebook. So you can install one too. That is right, understand? Yeah. So even you can try immediately. Any chance for you to try? But you may need, I don't know, the software requirements or your hardware requirements. So pull back, but any computer, this can be downloaded as I see. Utala Terunade? Hello? Can you hear? Yeah.
Yes.
Yeah. So try to download this cool pack. So this is very important. So this is a very handy tool. This is a very handy tool. And even you can do some simple cooling systems, heat transfer systems, calculations you can do over here if you need it. Anyway, this is a good tool. So so try to get this installed. Right? Try to get this installed. Very good. Cool pack. And the advantage here is even if you need to look for the property tables of water, whatever, you no need to look for different sources. Just open up cool pack. Okay. So if you need the superheated, yeah. So this will be the superheated. Uh, yeah. Anyway, properties. Let me open this and see. For water, if we need oil, water. This is only the temperature and pressure saturation. Saturation, temperature, and pressure. So if you need all the properties, you click the corresponding icon and then icon or a tab there. Select water, you will get this temperature, pressure, specific volumes, liquid and gas, enthalpies, R values, S1, entropy values, S1, so let's say this is the liquid SL and SG. So you can see these property tables here. Even you can specify the temperatures. Okay, temperatures. Yeah, it is going because in power plants we are using higher temperatures, so you can see here temperature only until 374, pressure 220 bar, quite high pressure. Yeah, so that's why. So this is very useful. So you can define your own ranges here. And you can make the screen big. Possible. Let's see the view. Anyway, this you may be able to. Even you can take the screenshots. Even you can do some calculations. Whatever possible. Take the printouts. Yeah. So this is very good. Okay. Even you can save some. You can open new ones. Yeah, whatever. Yeah. Anyway, it's good to have this cool pack software for the to have a property database. You can have plenty of data. If you need one more, it's a different types. See, so many. R134 a familiar, R21, 22, R290, the latest, the propane, and also R404. I hope you have heard those refrigerant types. So even not the but anything, even CO2 you can find here. CO2 also here. AR properties. See. AR property AR has R729. AR property C. Carbon dioxide. Yeah. Same C. You can get it. Any. So here even you can set the values. Maximum temperature what? Minimum temperature what? Even you can set the units either degree Celsius or degree Kelvin. Pressure in bar or kilopascal. Maximum, minimum temperatures and the steps. So here some data here, the critical temperatures and the minimum. Minimum means below this you won't get any data. Eh? Yeah. So this may be the sublimation point here. Okay. So if you look into water again, let's say what's the minimum? Sorry. Look into water again. See, minimum is yeah, T minimum is -100 here. So then there may be corresponding low pressures, T minimum. But here you can set the minimum temperature -2 or -20 even. Maximum temperature is 374. You can set. Even if you need only 200, you can change the settings. You make it okay. Then you get from -20 to 200. So step 1 degree or degree Celsius. This is bar. This is what we define. So very interesting, this one. Even there may be a possibility to copy the clipboards. See, we can adjust the columns as well. The column widths and all. So it is good, it seems. But I don't know whether this is possible to copy. Any chance to copy? Yeah, you can look into somehow you can export the data or whatever, but at least you can take a snapshot or whatever, anything possible. Yeah, try to utilize this. This is very important. So here you can see saturated values for water. Here you can see the left top column there. You can see saturated properties of water. Okay, good. Mm. And also there can be other tables as well. So if you look into the property tables, if you look into the other property tables, something like, let's say, there are famous Rogers and Mayhew property table. You can download it also from the internet. Rogers and
Excuse me, sir.
Mayhew. Sorry,
Sir,
Buddha? Yeah,
V1 VG is, oh,
sorry,
sir, screen is not display.
not displayed. Okay, yeah, okay. Yeah, Rogers and Mayhew. I'm going to look for that. Rogers and Mayhew. Yeah, I'm going to share with you the same. Right? Yeah, Rogers and Mayhew. Let's see. I'm going to share it with you. Rogers. See this one. You can download this from the internet. That is the standard. This is thermodynamics and transport properties of fluid. You can get this. So this is only here water. You have water properties, saturated water and steam. Even you may have some ammonia. So those are superheated water. And then you have compressed water. Yeah, somehow the properties. Ammonia is here. Then R12, R134, but this is limited, very limited. Only handful of properties of properties of some substances. Even atmosphere is here. But if you go to cool pack, everything is there, including this. That's why the advantage of having cool pack software. Also, let's say, let me go back to the cool pack again, just to share with you. Cool pack, I have to share a new screen then. A new share. So this is simple, something like orientation. This one. So let's say here you can see the cool tool cycle analysis. See, cool tool cycle analysis. See, here you can see cycle, single stage, two stage, cycles, even the heat exchangers, the evaporators, condensers, left side, you can see here. Okay. And also this R22, this is refrigerant calculator. This is heat transfer fluid calculator. Yeah, secondary fluids. Yeah. So this is refrigerant calculator. When you go here, refrigerant utilities. Very nice. Yeah. The refrigerant. Yeah. So you can see new messages here. Take that message out. So you can select the refrigerant here. Very interesting. Yeah. So any type here on this small box. Let's say water, pressure, temperature units. So you can give the values. Okay. Let's say temperature. You can give the values. Let's say temperature 100. Okay. Temperature, let's say 100. 100. Saturation. Sorry. 100 here. degrees Celsius. So if this is for the saturation here, so we need to see the corresponding pressure. See, pressure within brackets. See, so when you press this, see, 1 bar boiling temperature. Okay. If you need the specific volume, V of T, saturated liquid here, V of T.
Excuse me, sir.
Yeah,
Excuse me,
Buddha.
we can't see.
We can't see in this pop-up menu, sir.
Okay, yeah, okay. Yeah, I understand. Yeah, good that you mention it. So this is again from this R22 here. So refrigerant calculator is here. So you can select anything. So I just select water. So 100 here, whatever the temperature, let's say. And you can change the temperature to, let's say 50. Yeah. So saturated liquid is here. Let's say you need the pressure corresponding. See, the pressure is changing. Same way you can get this temperature, pressure, specific volumes, VT here. Yeah, see, things are changing. Yeah. So the gas here, yeah. So you can get the corresponding values and even you can add the refrigerant info. Yeah. So here only the, yeah, we didn't add the info yet. So you can add the information. This is so far only this much. So we will see temperature, pressure, V, enthalpy, H, HT. See the H values are changed. ST. See. So this is the liquid side. So at this temperature, saturated liquid properties are here. At point, see, you get all the data. Very interesting. And later you can copy, you can print. So that is the easiest way to get the data. Cool pack. Okay. If you are dealing with some refrigerants, let's say whatever. Methane is not using as a refrigerant. CO2, the latest. So at the refrigerant info, CO2 is here. CO2 refrigerant info. CO2, critical temperature, critical pressure, critical specific volume. Reference all here. Very nice. Now we can add, let's say at 50. What is the pressure? Click the pressure. So the saturated liquid values, you need the volume. See, oh, even enthalpies, entropies, yeah, anything. Let's say the CP value for liquid is okay. Yeah, at point, you get the values. Anyway, don't worry. You are still learning this. Once you learn, you can make use of this. A very handy tool. That's what, in short, I can say. Now I'm going to stop sharing this. Let's say now I'm going to close this. I'm going to open up another screen, same from the cool pack. See whether you can see this one stage. Yeah, can you see this? Can you see? Can you see? Maybe you cannot see. Let's see. Let me share with you. This again from the same software. So you can get this kind of cycles you can generate. This for refrigerant R290. Okay. So you can make use of that. So Also this one, you can see the when I click one stage here, okay, you can look into this tool analysis. Cycle specifications. So you can even edit this. Yeah. Edit cycle specification, even the refrigerant type you can change. Whatever the refrigerant, let's say 290. And then your evaporating temperatures, condensing temperatures, once you set all, you can generate the results. Okay. Anyway, uh, this calculated. Okay. Yeah. So try to download this cool pack and play around and see how useful of this, how useful this cool pack for you. So that is one of the message in today's lecture. So whenever need, I will use cool pack, but let's move with the notes and all now. Mm, Again, this is the Rogers and Mayhem thermodynamics property table. You can get this downloaded as well. Okay, just browse PDF. Just browse PDF under this name, JFC Rogers and YR Mayhem thermodynamics property tables. That's it. Property tables. Rogers and Mayhem. You will get this. Okay, you will get this. Okay, you will get this. Could understand? Can you understand? I hope you noticed this. Okay, very good. Thank you. Now I'm going to open Excel file. I copy here one portion. Maybe I copy and put into an Excel sheet. Okay, I copy this and I put this to an Excel sheet. Excel sheet. Let's see. Okay. I'm going to share the video. This one. So I just copy part of that. Okay, I just copy part of that. If I need to keep the Rogers and Mayhem aside, let me try how to keep it aside. Okay, keep it aside. Interesting. This one. Okay. So you can see the copy 1, 2, 3, 4 temperatures here. For the saturated water and steam, you can see this. Okay. Here are the data. It's the same data. Okay. So I'm going to type now. Can you see the screen? I'm going to type now the temperature. Let's say I'm going to mark this first. I will take the temperature degree 3 degrees. Okay. 3 degree. Three degrees Celsius. So I will write the 3 degrees Celsius here. Temperature. Okay. T degree means if we add 3 degree plus 273.3, this is the corresponding Kelvin temperature, this one. Okay, this is Kelvin. Okay, this is Kelvin. This is degree C. Celsius. Okay, degree Celsius. 3 Kelvin is this much. Okay. So, Uta, can you say this, what I'm doing? Hello?
Yes, sir. Yes, sir.
Yeah, okay, very good. Yeah. Now, I write this HF value here, not the unit, kilojoule per kilogram. This is 12.6. Okay. Hg, 2506. Later we will discuss what these are. 0.2. Okay. 2506. So, the middle term here, this is HFG. This should be HFG. HFG in the sense, in the Rogerson Mayhew table, PDF, you can see, I'm going to show you again. So the middle is HFG here. Okay. HFG is in the middle. But here this should be HFG. HFG is the notation is missing, but you can see HFG. HFG is here. Okay. So this is HFG. What is HFG means? Hg minus HF. You can see 2493 points. Okay. So HFG is a calculated property. Okay. For even HFG, if you know HFG and HF, you can get this. So the equation here is, okay, the equation here is HFG, sorry, HFG, let's see, FG is equal to Hg minus HF. Okay, Hg minus HF. So you know this. So in the notes you will say this. So this is the formulation for this. Okay, HFG. Okay. So you can write this in different ways. But this is this. So let me go to the third column here. This is SFG, the simple list. Simple list means for 1 kilogram, SFG is SG minus SF. Sorry, SF. So that's how it is. So you can see it. So if you take the SF value is 0.046. Okay. SG value is 9.076. Okay. So this is, you can write the formula. SFG is SG minus SF. See 9.030, it's the same. Okay. Also, I'm going to do one more calculation here. Okay. Let's say HFG divided by the temperature in kelvins. Temperature in kelvins. Temperature in kelvins. Okay. Let's see what is this. HFG divided by temperature in kelvins. Okay. This is equal to 9.03 divided by 276.3. Temperature in Kelvin is 276.3. What is this value? This value should be, sorry, HFG is, sorry, I made a mistake. HFG is 2493.6. HFG is 2493.6. This one. 2493.6 divided by TK is 276.3. So what is this value? So I calculated it here. 2493.6 divided by 276.3 is 9.02493. That is 9.025. Let's say that is 9.025. It's almost 9.03. Okay. So this is almost SFG. Okay. So this is the way in the property table the S values are calculated. This is how. Okay. This is how the S values are calculated. So you can see in the property tables, the calculations are done for the SFG as HFG by TK. Yeah, SFG as HFG by SFG is HFDG by TK. That's how it is calculated. SFG. Okay. So this tells SFG is the calculated property. Okay. SFG is a calculated property. So later we can learn what SFG means. Okay. SFG has a very useful application interest, but this is how SFG is calculated here in the table. Okay. This is how SFG is calculated here in the table. And this is how HG and HFG relationship here you see in the table. Okay. And this is how you see SFG and SG and SF connection. Okay. And this is the Kelvin temperature. Degree Celsius plus. Okay. Basically you see this. So this is the G value, Vg, the specific volume for the per kg volume of water vapor at this temperature, at this pressure. See, very low pressure. This is because this is a saturated water. So this is the temperature, 3 degrees. So pressure has to be very low for water be uh, evaporated and have a water vapor and liquid, the water and water vapor mixture. So this is the corresponding pressure. Okay. So you have to study this. Okay. You have to study the thermodynamics property tables. You study for steam. Okay. Study thermodynamics. Property tables or property table for water and steam. So this is very, very important. Okay. Because you can see these connections. And here this is HFG. Yeah? This is HFG. So this is HFG, even though it is not mentioned. That is HFG. I'll just fill that. Okay. Now, can you see this? Do you notice this? I hope you notice this. So SFG is a calculated property. Okay. SFG is a calculated property. Same is SF and SG as well. Okay. So what is SF value then? SF value. What is the SF value? So at 0, almost 0 here, SF is 0. Okay, 0 plus means this is 0. SF is 0. When 1 degree Celsius, SF is 0.015. From where this 0.15 value came? Okay, from where this 0.15 value came? Let's say example, let me try this value. 4.2 divided by 274.4. What is this? This is 0.0153. Okay, so what is this? So at 0, almost 0 here, your SF value is 0. Okay, so when you increase by 1 degree, your liquid energy rise is 4.2. That's why. So this is something like, let's say, this is something like 4.2 divided by 1 degree in kelvins. We can write this as 1 degree plus 273.4. This is 1.0153. Okay, 1.0153. Same way here. This one is 1 degree. This is 3 here. 2 here. So if I look into this, can you hear us? Okay, please try to follow. How to get this SF at 2? How to get this SF at 2? Okay, how to get this SF at 2? Okay, SF at 2 is SF at 1 plus the rise of SF from 1 to 2. So I write a formula here. SF at 1, we already calculated here. 0.0153 plus, okay. Here rise from 1 to 2. Enthalpy rise means the energy input is something like 4.2 again. 4.2. 4.2 divided by the temperature at 2 is 273 plus 2. 273 plus 2 means 275. Of course, 0.4. 273.4 plus 2. See what's the value. We will see what's the value of this one. So I put the equal mark here, equal sign. So you will get the value. See, 0.03055 means 031. Okay, this is very close to 0.031. Okay, for the nearest. Okay, third decimal. So this is minus 0.031. Okay, closest, right? You can see this is how the things are calculated. So if you need to look into SF at 3, are you there? I can see 17. Yeah, can you hear? Hello?
Yes, sir.
Very good. Okay. See how I am generating this SF at 3. Okay, so SF at 3 is SF at 2. SF at 2 we calculated 0.030551 plus. So energy required to raise the temperature from 2 to 3 here is at the liquid side is 8.4 to 12.6, means again 4.2. Okay, 4.2 plus, so 4.2 divided by degree 3 Celsius in kelvins, 273.4 plus 6 means 276.4. 276 point. Okay, so this is the one. So let me copy this here. So here I put the equal sign. So that the value will come as 0.0457. That is 0.046 to the nearest decimal. This is 0.015. Okay. Because you know thermodynamics property table means you should know how these values are generated. So you know how to calculate SF. Yeah, how you calculate SF? Using H values, using HF. SF calculations by using HF and temperature in Kelvin. Okay. Okay, very interesting this one. Eh? Yeah. Yes, that is very important. So you know how you calculated SF values. So this all SF. Today is a very important lesson you are doing. And then I am going to calculate SFG value. FG. This SFG here. How you are going to calculate SFG? This one. SFG as a calculated property. Okay. Yes, this way. We are going to calculate SFG on this column. Okay. Actually, for SF calculation also, we can have a simple formulation, same like this. Okay. SFG calculation is very simple. Okay. HFG by TK. Mode shifted because of this. Okay. So, Yes. Good. To the values. Be patient. So to get here. So what is this value? SFG is. Let me remove this column also. As I mentioned you, SFG, the calculated property. Yeah, you're familiar with this now. So SFG calculated property, let's say HFG by TK. So I do this way. For 2, it means interval so that below can be maintained. Good. Okay, going to be nice. 2, 3, 4. Even for 4 degrees C, we can do the same. Don't worry. SFG value. So now I'm going to calculate. For this SFG as calculated property, this HFG is measurable. 2498.3 divided by the temperature. Okay. At 1 degree means corresponding Kelvin is 1 plus 273.4. So this is the SFG value. Okay. This is the HFG value. So if I put equal sign here, you will get this. Let me turn this. Put the equal sign here. See, 9.105. 9. So this is 9.10459 means 9.155 almost. 15. So, sorry, yeah, 9.11. Okay, almost there. Here. So same way for the SFG here. Yeah, let's see, 2498.3. Okay. At 2, so this is at 1 degree Celsius, at 2 degrees Celsius, at 3 degrees Celsius. Oh, no choice. you have to bear that. Maybe something. Yeah, looks very noisy, but I'm very sorry. Yeah, I'm very sorry. It is noisy. Yeah. So here, for the 2 degree, HFG is 2495.8. 0.8 Lovisa Baki divided by 2 plus 273.4. Yes, so this is the HFD value. So I copy this here. Paste. In short, you should observe that these are calculated. See 9.062. See 9.071. This is quite close. because here our decimals are somehow truncated. Okay, that's why. So 9.06 to 9.07. Okay, 2495.9 here, 2495.9. 273. Yes, 9.062. So for the third one, again, HFG 2493.6. 2493.6 divided by at 3 degree means 3 plus 273. So copy this, paste, sorry. So we get the value for the formula 9.021. This is 9.03. 2493.6. 02. At 3 here is 9.0249. 249327, yeah. Three point three here. I think it's a 273.3 or 4. Maybe 0.3 here. Let's see. 9.273. I cannot remember that is 273.3 or 4. Anyway, this is how the values are calculated. Okay. So you know how to calculate SF. You know how to calculate SFJ. Okay. And then once you know SF and SFJ, SG can be calculated here using this formula. SG. Okay. SG is SF plus SFG. SFG. So this is the formula you can find the SG values. SF plus SFG. Okay. Yeah. This is how the values are calculated. Okay. This is how the values are calculated. Yeah. So you know that S values are calculated properties. S values are calculated properties. So somehow this knowledge of calculation is very important. So you even if you have these H values, you can develop the S values. you can develop this values. Okay. And what is this S means? S means what? S. Entropy. Okay. S. So H. S means entropy. Simple S means specific entropy. Yeah? And H refers to enthalpy. Enthalpy. Okay. Even here, I would simple S. So S, simple S, small s and small h is for the specific entropy and specific enthalpy. Specific means this is for only 1 kg. And this is specific enthalpy. Okay, specific entropy and specific enthalpy. S and H values. So H and S values are entropies and enthalpies. Okay. So now I'm going to the same Rogers and Mayer table here. This one. So you know from the H values how to get the S values. Okay. All the same. And when it comes to the superheated, again water and steam, you can see the same entropy, SG values, of course, all in gas. S values all in the gas form, superheated form. And the enthalpies, and the U means the U value, the internal energy value, and the specific volume is Vg. V, U, H, and S. Later we will see further on this. Today only we are just drilling how to read these tables and all, not to read, but how to get the values, how to derive the values. Okay. Now let's say I'm going to take a snapshot of this again for the superheated. I will copy this to the same table. Interesting. Eh? So you can see that here, same table. Now you see how these S values can be calculated. Okay. How these S are calculated. This is quite challenging. You can see. So here superheated means Now all S, no more SFG. This is the older versions. So now we have to look into this. So how to get this values? Okay. How to get this value? So this is temperature. So I hope you can see the screen again. So at this pressure here, example 0.01 bar, you can see the temperature is 7 Celsius and you can see the saturated values, the saturated vapor values. Later I will share with you what saturated vapor values are. And again, you have this. So let's see how these S values are calculated. Okay. How these S values are calculated. Okay. Let me try this solution here. This may not be correct because 50, 100 and all the, you can see from 100-degree gaps. Okay. But you can see some closeness. Okay, let me explain how I get this one. This 8.954. This 8.974 is this. Okay, 8.97. This S value. Okay, so this S. So now this is 9.27. So this S plus, yeah, this plus. Okay, this is like HFG by T. So HFG means now you have 2595 value here against 2514. So 2595 minus 2514 divided by the temperature 0.01. So 0.01 means 273.2 3 almost, 273.3. So that's how this value came up, 9.273. This is 9.24. There's a little difference. The reason is, so here from 0 to 50 degrees C, there is a real variation, but for 50 degree, I took this as in one shot. Like example, in the previous evaluation, we took from 1 degree to 1 degree. But here, from 0 to 50 degree. That's why if you have enough data, this can be more correct. Okay, this can be more correct. So here, this is the approach of evaluating is, but it's better to go from degree to degree. Okay, better to go from degree to degree. So I will do a simple calculation here. Let's say 10.670 plus, see here, you follow me, 3489 minus 3280 divided by, here the temperature is 400, so I just put 400 plus 400 and 500, so this is average. Let me say take this is 450 plus 273. See what is this value? 10 point. See 10.959. Okay. This is 10.960. You can see how close. Here also, instead of this 273 plus 50, if I took 273 plus 25, okay, because that's the average, 0 and 25, you can see 9.245, very close, 9.241. So this is 10.95. This is 10.96. Okay. So you will have some understanding on how these values are calculated. Okay. Same way we can calculate each and every. Okay. So you will feel this is very close. And even for this case, instead of 2 here, instead of 1, if you can take 1.5, the average, maybe you have a very close values. 9.09. I don't know what is this. 9.09 is SFG value. Anyway, I'll just leave it 9.1. So anyway, it depends on the calculations. Okay, it depends on the calculations. So you know, entropy values are calculated properties. So that is the bottom line of today's evaluation. Entropy values are calculated. Are calculated. Okay. So that is one of the messages today. And entropy values are calculated. Okay. and you can generate this value. So in the table, you should know how to generate these values. Okay, yeah, that is very important. So now I have to go to your notes. Okay, I have to go to your notes because you are somewhat experienced team, I believe so. So I'm going to look into the notes. Thermodynamics note. Let me see. Thermodynamics note. Thermodynamics. This is the thermodynamics note. Here, I'm looking for a table. Looking for a table. Let me look for that. This table. Okay. You have to do some self-studies. What is this table? Pressure, temperature, Vg, X values, degree of superheat, enthalpy, and internal energy. Okay. Steam table. Steam table. So what you have to do is that I hope you can see this. Okay, steam table. Steam table. Complete table 2. Complete table 2 using a steam tables. Insert a dash for irrelevant items and interpolate where necessary. Okay, this item. This item. You have to do this. Okay. So X, you will know what X means. Okay, so this is the one. So let me take a snapshot of this. Okay. You have this. So you can really check what this means. What this means. Example. Let's say temperature 90, you have Vg 2.364. So you can go to the cool pack, or even you can go to the Rogers and Mayer. Okay. Temperature 96. This is pressure temperature. This is temperature. Temperature 96. Temperature 96. Yeah. I will share with you. I will share with you the screen. Give me a second. Temperature 90. So this is the one. temperature 90, Vg is 2.364. Let's say whether this is okay or not. Temperature 90, Vg is 2.364. This is for steam. So let me go to, you have to keep this in mind. So let me go to the steam table. Temperature 90 and Vg temperature 90.
Excuse me, sir.
Yeah, Buddha.
We haven't seen that.
Yeah,
Menu.
I'm going to show you. Yeah. So this is your table, and this is the Rogers and Mayhew. So temperature 90 is here. Vg value is 2.361. Okay, 2.361. But on this table it is 2.364. So you can see that there is X value because this Vg value is greater than 2.361. So, but this is very close to liquid forms. Okay. So anyway, this is a realistic value. So let's say pressure 20, your H is 2799. Pressure 20. Pressure 20. So let me go to pressure 20 bar because I cannot see the units there here. Pressure 20 bar is here. Pressure 20 bar. H is 2799. H. So here you can see H is 2798. HG 2798. This is HG value. So this is something like saturated gas. So this pressure 22799. You have to look into the table and the data. You carefully review this. You have to simply check this. Pressure 130, enthalpy 3335. So pressure 130. Somewhere here, enthalpy is 3335. 130. 3335. 130 is here. This is 2662. So we surely know that at this pressure, 3335 means this is superheated. Okay, this is realistic. Somehow you can get. So X is irrelevant. So you can make dash here. Okay. Now you have to look for Vg and T. Yeah, at 130. Yeah. Very interesting. Yeah. You can go to Vg means superheated. So you know that. You have to go to superheated, pressure 130. To browse this, 130 is here. Vg 3335. Sorry. H is 3335, 130. See somewhere here. 333. You can see here. 3335. See 130. So you can get the values. Your entropy, your Vg value. See, you can fill all. Your temperature. Go up. Temperature is 500. Okay. So likewise. Pressure 38.2, you have X value. Yeah, you can try. Temperature 297, X value. Pressure temperature 2.3 and 2.3 bar 300 Celsius. Okay, yeah. So today you have to pressure 2.3 bar. You have only 2 and 3 only. 2 only you have. Yeah. Let's say first the saturated 2.3 bar. Your temperature is 124 only saturated. So this is surely superheated. So you have to look into the saturated table. Likewise, okay, this is for your self-study. So you take this tutorial table, partially filled one, and take the reference of this. Okay, Rogers and Mayhew or even Coolpack. Try to fill this. Try to fill this. Okay, so this is the coursework really. You try to fill this. Yeah. Actually, if you can do the complete tutorial 1.1 A, Harida 1.1 tutorial 1A, okay, 1.10. This is quite good. You will get a very good knowledge on this 1.10. Can you see this? Yeah. So this is somehow page number. You can see the page number 17. Maybe page number 17 of your notes. You will see this. Okay. This is a very good exercise to drill, and if possible, you can not to say if possible, you should have, if you have some difficulties, some issues here, you should raise and you should clarify this. Even I won't say this is perfect, there may be some issues, then you address those issues as well. See, even U value is here, U value. So this is interesting. So do this one. So to do this one, you have to have a prior knowledge of steam. So here you go through this. You go through this. Okay. You go through this. Thermodynamics charts and table under this. The study. Okay. Very simple things. Steam tables. You do this. Yeah. Some examples are here. How to read the tables. You can get it done. Okay. So perfect gas we will study later, don't worry. You look into the steam tables. Utala, okay? Can you hear me? Hello?
Yes, sir.
Yeah, very good. So you have homework really. You have homework means you are going for some self-studies. You're going for some self-studies. I just show you a tool, the Coolpack and the steam table, but I didn't explain you the table. How this table come? What kind of situation the table is generated, how these values are taken. I have a lot to explain you, but I have to give some initiative to you to go through and understand by yourself. Okay, go through and understand by yourself. So anyway, it's a responsibility for you to understand this, because last week I mentioned that you are learning not only for you. Okay, so be a selfless learner. You are learning for those who lost the opportunity to learn as well. So it is your responsibility to learn this and make use of this knowledge. So that is your responsibility. So you have to work very hard. With that attitude, you have to work very hard. Even I have to teach you, no? Yeah, because I also have the responsibility to support you on behalf of those who lost the opportunity. So that's why I am also supporting you. You also have to study very well for a purpose. So you have no excuse. Even I have no excuse because we have a purpose. Okay, that's why we have a purpose. So no choice. No choice, day and night. We have to sacrifice to get this knowledge, to support the societies, to support the others. Yeah. So we all are committed. Yeah. No choice. Yeah. That's why we are here together. Yeah. So no choice, no excuses. Yeah. So that's why. So Utala, you have to go through this. And now I'm going to explain a little bit of the experimental background of getting that property tables. Okay, of getting that property table, the experimental background. So let me, here you can see this table. So here in the experiment, you are maintaining a constant pressure. Okay. Then naturally when the water is there, together with the steam, there is a constant temperature. Okay. And through that experiment, you will be calculating this experimentally. Okay. And you have the U value. Let's take the U value at the moment. Yeah. And this is UG. Yeah, actually I can show you these values as well. But this experiment, let me explain this. Let me try. And then HF values, HG values, HFG. So these all are calculated in a laboratory scale test. This is a lab test. So this test is done in very careful manner, very slow, to assure no irreversibilities. That's why these entropy values can be calculated simply like example SFG is HFG by temperature in Kelvin. Yeah. So you can see here the enthalpy increase divided by the temperature in Kelvin, you get the entropy increase same way. Okay. Yeah. So you have to go through this, but basically this is a constant pressure closed system. Okay, constant pressure closed system experiment, and this is a very slow scale. I mean the time wise very slow changing. Yeah, dynamically extremely slow, extremely slow. Okay, and the constant pressure process. So at P equals 0.10 example, this was done first. Then you increase the pressure a bit, get the values, increase the pressure a bit, get the values, not only one time. You may be repeating this test several times. Yeah, repeating this test and get the average values for the particular temperatures, specific volumes, you will get the values. Okay, repeat the test at the same pressures, closed system, constant pressure, heat additions. Okay, constant pressure heat addition. So you can see at this pressure, your UF reference value is 0 plus, you see, HF 0, SF 0. So for this calculation, internal energy, this is the reference 0. Enthalpy, this is the reference 0. Entropy, this is the reference 0. Starting here, slowly these values will be increased. Okay. See, U value of this same as HF values here. UF value same as HF value. Interesting. Okay. Yeah, HF value. Yeah. But the UG and HG is different. Yeah. So UF same as HF because that's the basis. Yeah. So you can notice this. You have to learn a lot of this. Learn a lot of this. So today, no much explanations. Even coming week, we have to discuss on the saturated water and steam. So that's about it. And even the notes, even in the notes, today, the notes. So So we came only to that day we discussed the specific heat capacity values, how those are changing, iron, water, air. So the specific capacities, heat capacities. Then we came for the constant temperature and constant pressure, specific heat capacities, and even H we have not defined yet. Okay, H enthalpy we have not defined yet. So let me define this in the next class. In the next class, I will define enthalpy very nicely. This is from NASA presentation. This is not done by me anyway, don't worry. This is a NASA presentation. So that's how the enthalpies are defined. There are purposes to define this kind of parameters. So you may feel that enthalpy also has some calculation interests. Okay, has some calculation interest. So enthalpy combined with some properties, internal energy plus the pressure and volume. So I will explain the practical aspect of this in the next session, because today even we are a bit tired. So I will explain this as well in the coming sessions. Back to the slides, we will go through this. So today I'm going to stop now because time has almost reached the end maybe for you. So let me continue this. If possible, I will try to mail this one as well. But you have the notes and all, you have the notes. So note is good enough and do that exercise. And if possible, before next Monday, please email me. Please email me. Because that has a good interest even when you design the steam turbines, the steam turbine calculations, even the boiler calculations, power plants, reading of steam tables, important. Those have some practical aspects. That's why I gave you the steam table for you to study. Okay, Bhutala. So let me stop the class today. See you next week, and I will post some notes for you. Okay. Try to download, so you have some homework. Rogers and Mayhew you have to download. Coolpack software you have to download. And sorry to say that if you don't have a notebook, downloading this to smartphone, I have no idea how is it, but don't worry. You can download the Rogers and Mayhew PDF. Okay. Yeah. Don't worry. We are all living with limited resources. That is fine. Even not downloading Coolpack won't affect your knowledge. Right? It's a tool only for you to make the things easier. That's all. But anyway, whenever the necessities come to calculate the data and all, I will provide the data values. At least on my notebook, we have Coolpack. On my notebook, Coolpack is not only for me, but for you all as well. So let me try to share on and off whenever we need it. So till then, manage with the existing resources and don't worry. Yeah, don't worry. Yeah. When it comes to resources, of course, some are more resourceful, some are less resourceful. Don't worry, that is not a big deal. Nothing to do with that much of resources, but try, because your best resource is your brain and mind. Yeah. So you respect those, you try to overcome this. Okay. Mainly try to get the good concepts, applications. So today, steam tables, those have very good application interests, even for power plants, for refrigeration, heating applications, the thermal applications, a lot. Yeah, water-based applications, huge application. Yeah. Even if you need to design a water heater, you have to have the steam properties. If you need to design a water heater, yeah. See, we are talking some practical aspects as well. So even in the boiling a kettle or designing a kettle, still you need the steam properties. You have to understand the behavior of water as well. Without knowing the steam properties, you cannot design a kettle because you are using the kettle to boil water. Boiling is starting from the room temperature. Yeah, you have a lot of practical aspects of using this steam table. Let's see how to work those out. Okay, Bhutana. So let me stop the class today. Go through the notes. Your notes are quite complete. No matter you have this, yeah. No matter.
Excuse me.
Yeah, Bhutana. Anything? Yeah, please tell me.
Sir, can we go to university for library?
Bhutana,
It's
these
possible?
library is not possible, but let me send you a link to download some thermodynamics books if possible. I don't know whether you're asking not only for the thermodynamics, but for the others as well, maybe. But nowadays, no one is allowed because of Corona. Even for your workshops, you have to go to VTA without coming to the university.
Okay, sir.
Yeah, VTA is open, that's why. So you have to arrange those, but you are not allowed to come to the university. But there can be free downloads of books. Yeah. So this is
Sir, do
the.
you have any previous past papers, sir?
Yeah, I can pass it to you. I can pass it to you. Exam will be quite easy. Don't worry. Will be quite easy. So if you
Thank you,
try
sir.
your best, I will assure that you will get a good pass. Don't and
Thank you,
it's a mix of the practical and the theoretical aspects. And it is for you to pass and scoring. That's why it is for you to pass. So please understand this, then you are done. Don't worry. And make sure that for the first attempt, you have to sit. You have to sit and you have the most highest chances of pass the exam well is from the first attempt. The first sitting. Don't miss the exam. That is extremely important. That is extremely important. Don't miss the exam. Yeah. That is very important. Okay, Bhutana, any more questions? Any more questions? Yeah. So we will stop the class today. Actually, if we can do this in the classroom, we can discuss very nice examples. And we can have a very nice approach for the subject. But here, you are there, I am here and using the Zoom and the limited interface facilities. So those are the challenges. Otherwise, this will be quite nice and very real subject. Anyway, we will try to manage that liveness even with this situation. So we will try our best, Putan. Any more question you can post, you can discuss. Yeah. Okay then. So I will stop the class today. Yeah. Okay. Yeah. Good.
Thank you very much.
Thank you. Thank you for your attention. And see you next week, Putana. Okay, anything, just let me know. Okay, bye. Bye.